Hi everyone, my name is Saldina and I make IT and programming related videos on Code Beauty channel. And today we will go together through C++ crash course. But first, I want to thank Brad for giving me this opportunity and for giving me his platform to share the knowledge. And I would especially like to reach maybe some more girls and women and encourage them to enter this industry, but all the male viewers are welcomed as well. So thank you very much, Brad. Some of you who clicked on this video are already familiar with C++ to some extent. Some of you are not at all, which is fine because I'm going to introduce you to C++. C++ was created back in 1980s, and it was created with two other programming languages in mind. One of those two was Simula, and at that time Simula was a language that was very understandable by humans. But at the same time it was very slow, so they needed to combine it with another programming language, a fast one, and at that time the best choice for that was C programming language. So they took the best from both worlds, and that's how C++ was born. Now, with that being said, C++ is general purpose language. That means that it is not specialized for only one domain, but it can be used to solve a wide variety of problems. What are some examples? Well, for example, you can build browsers with C++. Your browser was probably built with C++. And then games as well, the ones that are very fast, those have their engines probably written in C++. And then other programming languages, operating systems, most of them have their core written in C++ or C programming languages. Your car, your mobile phone, your computer, a lot of drivers and embedded systems of those are written in C++. And then there are always examples of compilers, interpreters, media editing, data mining, and machine learning as well. Those are examples of things that are very heavy on the CPU. And you are definitely going to notice a difference between a solution for those that is written in C++ and then the one that is written, for example, in Java or C# or Python or Node.js, because C++ is so much closer to the hardware, and that allows it to manage CPU and memory and resources in general very efficiently and very fast. Now, with that being said, C++ is not going to be exactly easy to learn because C++ is a very big language and there is a lot of things to learn. However, if you are someone who is interested in the things that I mentioned, or you are interested in competitive programming, for example, then you definitely are going to benefit from learning C++. Now, there are a couple more things that are important to mention when it comes to C++, and those are that C++ is compiled language, and that means that the code that you write first has to be converted in a code that your machine can understand, and that is what compiler is used for. C++ as well is case-sensitive language, and that means that it is going to matter if you are using uppercase or lowercase. And C++ is as well statically typed language. That means that once you declare a variable, you cannot change the type of that variable. So once you declare it, you assign it a type, and then later you cannot assign it a variable or a value of a different type. In order to start writing C++, you will need just a text editor and a compiler. However, what I would recommend is using an IDE, meaning Integrated Development Environment. And that means that it is going to have everything that you need in order to write your code, compile it, and debug it on one place. Now, there are many IDEs to choose from. You can use code blocks, you can use Eclipse, but the one that we will be using is called Visual Studio. And here I'm going to insert a clip on how you can download and install Visual Studio, because depending on your connection and your computer, that can take a couple of minutes. In order to download your Visual Studio, you will have to navigate yourself to this page here. So visualstudio.microsoft.com/vs, look for that link in the description of this video. And then you click here, Download Visual Studio, and you are going to select Community 2019. You can download that for free. So once you have this installer file, you are going to click on that. And then here you should click Continue. And now this should this shouldn't last long. Okay, now we have this window here, and what you should select here and what should be enough for this course is going to be desktop development with C++. So I'm going to select that, and as you can see it is 7.04 gigabytes, so it is going to take a couple of minutes, so I'm going to pause the video here. So just click install and that should be pretty much it. Let's now create our first Visual Studio project for a C++ console application. So I'm going to open my Visual Studio, and then here I will select create a new project. Now here I want to select C++ console application, so I'm going to type that C++, and then here it is, console application, and then click next. And here you will have to name your project and your solution, and I'm going to say CPP crash course, like this. So CPP crash course, and then click create. And now your project, your solution is being created. Okay, now here we have something called Solution Explorer, and here you have the project that we just created, and then here in this source files folder you have cppcrashcourse.cpp file, which is this file here, the one where we will be writing our code. Now, as you can see, we have gotten some default text when we created our project. Now these are examples of single line comments. This is a single line comment, and then this is a single line comment as well. And for creating a single line comment, you use this // and then your comment is not going to be compiled, nor your computer is going to try to understand your comment. It's just for you. So I'm going to delete this because we don't need it, and then this part here as well. Great. And then now, as I already said, C++ you have to compile. So how do you compile your code? How do you build your code? You click here, build, and then you can say build solution. And here you will get a message. It says once succeeded, meaning that you don't have any compile time errors. Now you can do compiling and running your code all at once. So you can click here, this local Windows debugger, or you can click debug and then start debugging, whichever you prefer. And now your program has started, and as you can see we have gotten this hello world message that is written here, and we have as well this junk text which we want to remove. So I'm going to use a command for that, and that is system, and then here you say pause greater than 0, like this. So now if I run my code again, you can see that it has only this hello world message. Excellent. Now let's add another message. So I'm going to copy this line of code, and let me copy my message as well. So here I want to say, for example, welcome to C++ crash course, and an end line, so a new line at the end. And as you can see, in order to write out a message to our console, we use this cout command, and then this std is a namespace. So it is a standard namespace that you have to use in order, you have to include it in order to use this cout command and many more. So now when I run this, you can see that welcome to the C++ crash course has as well been written out in our console window. Okay, now the first thing that I want to do is going to be really to include this std namespace at the beginning. So I'm going to say using namespace std. Now here I have included this standard namespace, so I don't have to write it here nor here. I can remove that. However, I want to say that this here is not going to be the recommended way of doing things, because this here is going to include many more things than just ones that we will need for this application. However, I'm going to use this in order to save some time, but the recommended way would be to use only the things from this namespace that you will be really using in your application, so only include those. Okay, now I'm going to delete this, because the next thing that we will be talking about are going to be variables and data types. A variable in C++ is just a container that takes memory, and that container can hold a data of a certain type. Now that type in C++ can be an integer number, it can be a floating point number, it can be a character, a Boolean value, a string, an array, and here I want to show you the most basic data types, and then later in this course I'm going to show you how you can create your own data types in C++. Now let's create a couple of variables. First one that I want to create is going to be integer variable, so you say int, and let's give it a name. Let's say age is equal to 25, so I have assigned a value to my variable. You don't have to assign a value to your variable when you create it, and you can change that value later as well. So you can say age is equal to 26, for example. However, if you say that your variable is, for example, const, then you will not be able to change the value that you have assigned to your variable. As you can see here, it says expression must be a modifiable value, meaning that this here is not a value that you can modify because it has been declared as constant. Okay, so I'm going to remove that for now, or you can just not assign a different value to it, whichever you prefer. Now, another type that I want to show you is going to be float, meaning floating point number. And let's say, for example, weight, and here I want to assign 65.5, for example, kilograms. So that would be an example of a variable that stores a decimal point number. Now, another way to store a decimal point number, another type, is going to be double, like this. And difference between float and double is that double can store double the data. It is double size of float, which means that it can show a larger number, it can hold larger number, or you can represent a number to with more decimal places, to a higher precision. So I want to say, for example, balance, meaning bank account balance. If you had a lot of money and you want to store that in a variable, you are going to use double for that. So I'm going to say, for example, 12345.67, or you can store much bigger number. We are going to see that later, how big of numbers you can store in each of these. Now, another type that I want to show you in C++ is going to be a character. So for that you use char variable, and for example, let's say gender, like this. And then in order to assign a value to your to your character variable, you will use these single quotations, and let's say that you use M for male and then F for female, like this. And as I already said, in order to assign a value to a character variable, you use these single quotations. Now, another type that I want to show you that can store more than one character, it can store more characters, is called string, like this. And let's say username, and for that I'm going to use these quotation marks, and for example, code beauty, like this. Okay, and as you can see, in order to assign a value to your string variable, you use these double quotations. Okay, and then the smallest data type in C++ is bool. So you say bool, and let's say is today sunny, like this, and today is not sunny. I mean, it is currently, but it wasn't like 2 minutes ago. The weather is just blah. So I'm going to say false here. Okay, and then another type that I want to show you is going to be array, how you can create array in C++. And you can look at an array as a collection of variables of a certain type. Now, array takes a continuous space in memory, and that means that when you declare an array, you will have to specify its size up front. Now, in C++ as well, you cannot have an array that stores a character and then an integer and then a string. So for those of you coming from JavaScript world, I'm sorry. So in C++ you cannot do that. So you have to specify the type of your array up front. So you have to say, for example, string, and then let's say colors, like this, and I want to have, for example, 5 colors, and here I want to specify those colors. So I'm going to say red, and then let's say green and pink, and then blue, and let's say black, for example. So this is going to be my array of colors. Now, if you create your array and then you initialize it, you can omit this size of your array, and now your array is going to have the size of 5 of these string variables. And you can as well initialize your array and say that it is going to have a size of 10, for example, but that you want to initialize only the first 5, and then you have 5 spaces, 5 of these variable places free to add later. Okay, and then you don't even have to initialize these up front, so you don't have to give a value to your variables that you are storing in your array initially. Now, after I have created this array, let's show how you can write out the value that is stored at a specific position of that array. So for that, I'm going to use cout command. And let's say, for example, that I want to write out whatever is stored on the first position of my array. And for that, I'm going to use index of 0, because indexation of your array starts with 0. So indexing, actually. Now, when I say cout colors of 0, I expect to see this red written out in my console. So when I run my program, you are going to see that it says red. Now, if you want to reassign the value that is stored on this position, in order for that, we are going to use another command, and I'm going to say, for example, cin, and let's say colors of 0, like this. And now I'm expecting my user to console input the value that is going to be stored at this first position of my array. So when I press this, you can see that my cursor is blinking. And let's say, for example, that I want to say yellow. That is the color that we haven't, I haven't written out this value. So I'm going to stop my program, and I will have to, again, write out the value that I have stored on this first position. So I'm going to run it one more time, and I'm going to say, for example, yellow, like this. And then, as you can see, it has written out yellow as the value that is stored on the first position of our array. So we have seen how you can enter value in your application. For that, you use cin, and then you can as well change the value that you are storing on a certain position of your array by just saying, for example, colors of, let's say, 1, and then you hard code that value here. So you say, for example, gray, like this. Okay, so as I said, since your array is holding a continuous space of data in memory, that means that you will have to give it this maximum amount on its creation. And in this particular situation, this means that your colors array can hold 10 strings, not more than that. Now, because your array is holding that continuous space of data in memory, once you come to that max limit, you will have to recreate your array. You will have to reinitialize it so that it can take that continuous space of memory somewhere else, bigger space of memory. Now, because of that as well, accessing these members is going to be quicker because they are one after the other. Now here, I have shown some of the most important basic data types in C++, but there are variations to these. For example, you can say that you want to store only positive numbers in your integer, or you can say, for example, that you want to use long int or long int in order to store a bigger number in your integer variable. So there are many variations to these. And in order for you to see that, I'm going to include a table here. So if you want, you can pause the video and check that out for a couple of minutes. And before we continue, I want to make a quick digression because I know that some of you are wondering why I'm using this light Visual Studio theme. It's because I don't have any other lighting except the one coming from my monitors. So if I use dark, then you wouldn't be able to see me. That's the reason I prefer dark Visual Studio. Okay, now the next thing that I want to talk about is going to be conditions, selection in C++. Meaning how can you execute one part of the code rather than the another one depending on a certain condition. And in order to demonstrate that, I'm going to use this variable, is today sunny, and now I want to check it. I want to check if is today sunny, and if this here results as true, I want to write out a message to my user. I will say, go to the park, like this. And let's add end line. So if this here is true, our user has to go to the park, else, meaning if this here results as false, I want to write out a different message to my user, and that is going to be, for example, take an umbrella. Okay, now when I run my program, since this variable here is holding the value of false, it says take an umbrella. Okay, now I'm going to stop my program, and there is as well shorter way to write if-else statements, and that is going to be using ternary operator or conditional operator. And what is the syntax of it? You first specify the variable or condition expression that you want to check, okay, like this, and then you put question mark. And after this question mark, you are going to specify whatever is going to be executed in a situation where this here is true, so this line of code. And then in the case that this here results as false, you are going to execute something else. So you put this column sign, and then you put the line of code that you want to execute if it is false, like this. So now I'm going to comment this. And as you can see, this is multi-line comment. And now if I run this, you can see that it says take an umbrella. So this condition has been checked and it resulted as false, and this part here has been executed. Okay, I'm going to stop my program and I'm going to comment this so that it is not executed anymore, and this here is single line comment. Now I'm going to uncomment this. Okay, and now I want to show you how you can bind and nest your if-else statements, meaning how you can make if and if else, and how you can make if or if else. In order to do that, I'm going to add another variable, and let's call that variable, for example, is today weekend, like this. Okay, now what I want to do is I want to check if is today weekend and at the same time is sunny, like this. And in a situation that today is weekend and it is sunny, I want to write out the message, go to the park. Else, what I want to do, I'm going to remove this. And in a situation where either one of these results as false, I want to check something else. So I say else if, and then I say, please check, is today weekend, like this. And then check as well if it is not sunny, like this. And in that particular situation, what I will do, I will write out something else to my user, and that is going to be take an umbrella. So let's write out go to the park, but take an umbrella. So it is still weekend, but it is not sunny. And then let's cover another situation, and that is going to be our final else. And in that situation, what I want to do is I want to say to my user, for example, go to work, like this. Okay, now this was an example on how you can write multiple if-elses, and now if I run my program, you can see that it says go to the work, because this variable here is false and then this one here is false as well, so these two have not been executed, and then this final else has been executed. Okay, now if I change these and I say, for example, that today is weekend and it is not sunny, and I run my program, it says go to the park. It says go to the park. Okay, go to the park, but take an umbrella. Okay, we should correct that. Okay, now I want to show you something else, and that is going to be how you can nest if-else statements. So I'm going to comment this here so that it is not executed anymore. And then I want to show you how you can nest your if-else statements, and that is going to be our following example. So for example, you say if, please check, is today weekend, like this. And then if this here results as true, what you can do is you can check something else, and that is going to be if is today sunny, like this. And then if today is sunny, what you can do is you can write out a message to your user to go to the park, like this. But if today is weekend, but today is not sunny, then you write a different message to your user. So you say else, and then you say go to the park, but take an umbrella with you. Okay, now, in a situation where this here results as false, then you are going to execute another part of the code, and that is going to be this one here. So you say else go to the work, like this. Okay, now when if I run this program, let me just show you whole code like this, and if I run this program, you can see that it says go to the park but take an umbrella, because today is weekend, but today it is not sunny, so you can go to the park, but you have to take an umbrella with you. Okay, now I'm going to stop it, and let's do let's say that today is sunny. That is true as well. And if I run it, it says go to the park because it is sunny and it is weekend. Okay, now both of these do the same thing, this part of the code and then this part of the code as well. It just depends on how you really want to write this code. Let's now talk about switch case. And switch case is a form of selection that you use when you have multiple options to choose from, so multiple cases. And switch case is usually used when you don't necessarily check on a Boolean value, so you check on some other data type. So I'm going to create here an enumeration. So I haven't mentioned enumerations earlier, but I'm going to show you how you can create an enumeration in C++, because we are going to use that for this example. So you say enum, and then let's call this enumeration iColor, like this. And then here you put variants, you put elements of this enumeration. So you say, for example, brown, and then blue, and then green, I think, and then we have gray as well, and let's say other to cover other possible eye colors, but let's say that these are the main ones. So now we have created enumeration called iColor, and we have given it these 5 values, these 5 variants, so brown, blue, green, gray, and other. And let's now create a variable which is going to be of type iColor, and let's call it iColor as well, only lowercase e, like this. And I'm going to give it a value of brown, because that's my eye color, I guess. Okay, and now I want to show you how you can use switch case in order to check for all of these 5 values, and then write out how many other people have that particular eye color. In order to write your switch case, you say switch, like this, and then here in these parentheses you put the variable that you want to check, like this. And now in the curly brackets we are going to cover all of these 5 cases. So you say case, and then let's put brown first. Okay, now in the case that our user has brown eye color, I want to write out a message to my user, and I want to say that 80% of people have brown eyes. Okay, and let's as well cover all of these other 5 options. So I'm going to copy this, and I'm going to say in the case that eye color is blue, I'm going to say that I think 10% of people have blue eyes, like this. And then in the situation where our user has green eyes, I'm going to say that I think 2% of people have green eyes, and then check gray, like this. 1% of people has gray eyes, like this. And then let's cover this other case, meaning all of the other colors, and let's say that 5%, or how many is left, 7% of people have some other eye color. 7% of people have other eyes. No, 7% of people have some other eye color, like this. Okay, now one thing that we are missing here is going to be break statement. So I'm going to write break, like this, and I will have to copy this on all of my cases. And this break is used in order to stop your switch case. So once you found the right case, the right code to execute, that code is going to be executed, and then you break your switch case, which means that other cases are not going to be checked, but the first one that is executed, after that, when you find break, you are going to leave your switch case statement. Okay, now when I run this code, it says that 80% of people have brown eyes. Let's change this to say, for example, blue, like this. And now it says that 10% of people have blue eyes. Now, since this enumeration here, these variants in the background are really integers, which means that this here has the value of 0, and then this here has the value of 1, and then 2, 3, 4. That means that here it is really checking integers. Now, here I can put an integer as well then. So I can say, for example, 99. And that situation is not covered in this switch case. So let's cover all of those situations where our user puts a value that is not valid, that is not covered with any of these cases. So here I want to write out a default case, which is this one here. And what I want to say in this default situation is going to be following. So I want to say not valid eye color. Okay, and now if I run this and I have hard-coded this 99 value, you can see that we will get this not valid eye color, because that is how our switch case works. And then here you can put break if you want, but you don't have to, because you are not going to get that bug that you are going to get in the case that you, for example, here don't have break. So let me delete this break, and let's put this eye color to be blue. So I'm going to copy this variable and paste it here just to demonstrate to you what is going to happen. And now, as you can see, it says 10% of the people have blue eyes, and then it continued executing other cases because we have forgotten to put this break statement at the end of this line here, so at the end of this blue case. The next concept that I want to talk about are loops, and loops are used when you want to execute the same part of code multiple times, or as long as a certain condition is true. And first I want to show you an interesting concept, which is a concept of infinite loop that you can make in C++. And then I'm going to demonstrate examples of while loop and do while loop. And I'm going to show those two together because I really want to point out the difference between while loop and do while loop. So the first one that we will create is while loop, and on that example I'm going to demonstrate an infinite loop. So let's create a variable which we will use as counter, like this, and let's initially give it a value of 1. Okay, now what I want to do is I want to write out the syntax of while loop. So you say while, and then in these parentheses you put the condition that your loop is going to check each time that it wants to make an iteration, and then in these curly brackets here you put the block of code that your while loop is going to execute. Now here I just want to write out the value of my counter, so I'm going to say cout counter and then add end line like this, and then here my condition is going to be for this to be iterated as long as my counter is less than or equal to 10, like this. Now this, what we have written here, is an example of an infinite loop. Why? Because here we haven't changed the value of our counter. Our while loop enters this block of code and writes out the value of our counter, and then it goes back here and then checks whether this condition is true. This condition is true because our counter is 1, and then it iterates through this again and again and again because we have never changed the value of our counter. And if I run my program, I can demonstrate that. And as you can see, our loop is running. And that was an example of an infinite loop, and you can make infinite loop with either while or do while or for. It really does not matter. If you skip the step of changing the value of your counter, or if you skip the step where you are going to make this condition here false at a certain point, you have gotten yourself an infinite loop. Now, how we can reach this condition here, how we can make it false at a certain time? Well, we can say counter plus plus, meaning in each iteration of our while loop, we will increment the value of our counter by 1. So now when I run this code, you can see that our while has been executed 10 times, and then it has stopped because in 11th iteration our counter was 11 and this condition here was no longer true, so our while loop is not going to execute at that point. Okay, so that was an example of while loop. Let me now show you the example of do while loop. So I'm going to copy this line here so that we can really make a difference between what our while loop has written out and then what our do while loop has written out. So in order to create a do while loop, you say do, and then here you will put your code that you want to execute, and here you put while. So at the end you put the condition, and I want to use the same condition, so I'm going to copy this condition from our while loop, and as well I want to copy this here like this. Okay, so now when I run this program, you can see, oh, we have used the same counter. So what I have to do is I have to change this counter. So I'm going to use different counter for my do while loop. So I'm going to say, for example, do while counter like this, and let's very quickly change this counter to be our do while counter like this. Okay, now it should work. And now if I run my code, as you can see, it says while loop, and then our while loop has run 10 times, and then our do while loop as well has been executed 10 times. Now, what is the difference? The difference is in the following. Your do while loop is going to execute at least once, always, but your while loop doesn't have to, meaning in a situation where this condition is false, there is not going to be iterations of your while loop, and if this condition is false before your first iteration started, then your while loop is not going to be executed. Your while loop is not ever going to enter here and execute this block of code. But your while loop, it first says do, and then it checks this condition. So in order to demonstrate that, I'm going to change the value of this counter to be 11, for example, and then here as well. And now if I run this code, you can see that our while loop has not been executed, not once, but our do while loop has been executed once. Even if we have here this do while counter is less than or equal to 10 and our counter is 11, we have had one iteration of our do while loop because it first does and then checks conditions. So that is the difference between while loop and do while loop. Now, another loop that is often used in C++ is for loop, and for loop is often used when you know in advance how many iterations you will have. Now, one example could be to enter or to write out elements of an array. So let's do that. Let's create an array of strings like this, and let's call it animals, for example, and let's say that we will have 5 animals, and I'm going to initialize this array. So cat, and then dog, and then let's say, for example, cow, and goat, and let's say bee, and I'm on purpose choosing animals with short names so that I don't make typo, and I'm sorry if I did somewhere in this course. Okay, now when we have this array, what I want to do is I want to iterate through all of the elements and write out the values. So for that I will be using for loop. So you say for, and then there are 3 things that you will have to give to your for loop. So the first one is going to be to initialize a counter that you will use. So I'm going to say int I is equal to 0, and I want to start with 0 because indexing of our array starts with 0. So the first element that we would like to access is going to be the one on 0th position. So the first thing that we give to our for loop is going to be initial value of our counter. After that, we will need to put a condition. So let's say while I is less than 5. And then the third thing is going to be to either increase or decrease value of this counter so that we don't end up with an infinite loop. So let's say I++. Okay. And then what I want to do here is I just want to write out the element that has that index. So I'm going to say cout, and then let's say animals of that index. So animals of I, and let's add end line. And now if I run this code, as you can see, we get these cat, dog, cow, goat, and bee. So all of the elements of our array. In this chapter, I want to talk about functions in C++, and a function is a block of code that is organized and grouped together in a way so that it can perform a specific task. Now, dividing your code into functions is going to make your code reusable, and that is going to make your code easier to read and easier to maintain. Now, I want to show you two examples. I want to show you an example of function that returns a value, and then an example of function that does not return a value. And the first one is going to be a function that returns a value. It is going to be a function that is going to sum two numbers and then return the result to us. So I will say float. That is going to be the return type of our function. And then I will call my function sum. And here you pass arguments to your function. So you say which arguments your function is going to receive. And those are going to be two arguments, both of type float. So float A and then float B. Let's call them like that. Let's call them A and B. And this here is called function declaration. Now this function is missing definition, and definition of function goes after your main function, and then declaration of function goes before your main function. So I'm going to copy this and then paste it here, and here I want to write the definition of my function that is called sum. So this function is just going to sum these two numbers and return the result. So I'm going to say return A plus B, like this. Okay, now how do you invoke this function? Here in my main function, I will say sum, and then you pass two arguments, two parameters to your function. So here I will say, let's say 2.2, and then the next one is going to be 5, like this. And what I want to do with this function is I want to write out whatever this function returns to me. So I want to write out the result of summing these two numbers. And for that, I say cout and then write out the result. And let's add end line at the end. And if I run this, as you can see, it has written out the result of 2.2 plus 5. Now, as I said, this is going to make your code reusable. So if I duplicate this, and here I say 5.5 plus 3, for example, and then here I say 4 plus, let's say 8, and if I run my code now, as you can see, here are the results of summing these numbers that we have passed to our function. Now, that was an example of a function that returns value. In this particular case, it returns float. And another type that I want to show you is going to be a function that does not return a value. So in order to declare that function, you will use return type void, meaning nothing. So you say void, and then let's say that that function will be called introduce me, like this. And that function will receive two arguments. The first one is going to be name, and then the second one is going to be age. So I will say string name, and then let's say int age, like this. Now, as I already said, this here is the declaration of your function, and then definition goes after your main function, so here. And here I will say that this function is just going to write out whatever we pass to it. So cout my name is, and then name, and let's add end line as well. And I want to write out age, so I will duplicate this, and I will say I am, and then age variable, and let's say years old, like this. So my name is, and then this name variable, and then I am, whatever our user has passed as age, years old. Now I'm going to invoke this function as well, and I cannot write out this function, so I cannot use cout operator, but I just invoke function that is going to be of type void, of return type void. So I will say introduce me like this, and here I will pass, for example, Saldina, and let's say that age will be 25. And now if I run this function, as you can see, it says my name is Saldina, I am 25 years old. And let's use it one more time. So I will say, for example, Anna, and let's say that she's going to be 35. And if I run it, as you can see, it says as well, my name is Anna, I am 35 years old. Now, there is as well a concept of default parameter in C++. So for that, I'm going to assign a default value to my age parameter here, and I'm going to say that default value is 0. And now this means that you don't have to pass this age parameter to your function anymore. So if I delete it from here, and then I run my function, I run my program, as you can see, it says, my name is Anna, I am 0 years old. And now you can do whatever you want with your function in the situation that you haven't passed this age parameter. In the previous chapter, we talked about functions, and then in this chapter, I want to talk about pointers. So let me explain what are those. As I already said, a variable is a container that can store a value, and then a pointer, instead of storing a value itself, it is going to store an address of a variable. So for example, an integer variable can store an integer number, so a whole number, and then an integer pointer is going to store an address of an integer variable. Now, pointers in C++ have many uses, and if you really want to understand and work with pointers, you will probably have to take more time than just these couple of minutes that I can dedicate to pointers in this crash course. However, in this course, I will explain two of the most common uses of pointers, and those are going to be using pointers with functions and then using pointers with arrays. Now, the first example that I want to show is going to be using pointers with functions, and in order to demonstrate that, I will create a function and then I will introduce a problem to it. And then in order to solve that problem, we will use pointers. So the first thing that I will do is going to be to create a variable, and let's call that variable my age, like this, and I'm going to assign it a value of 25. Now, what I want to do next is I want to create a function. So that function is going to be of return type void, and let's call that function celebrate birthday, like this, and it is going to receive an integer parameter which is going to be called age. Now let's define this function here. So the only thing that this function is going to do is going to be to increase the value of this variable, so increment it and then write out a message. So this function will say, yay, celebrated. Let's say I want to write out this age. Oh, I want to write out this age, and then let's say birthday. Okay, and let's add end line, like this. So this function receives age variable, increments that variable, and then writes out, yay, celebrated 25th, 26th, 27th, whatever, birthday. Okay, now let's invoke this function here, this celebrate birthday function, and I'm going to invoke it in my main function. But before invoking it, let's just write out this value, this my age. So I will say cout, like this, and then let's say before function, like this, and I want to write out my age here, like this. And now let's invoke this celebrate birthday function here, and what I want to pass to this function is going to be my age variable, like this. And then after this function, I want to write a message as well. So I want to say after function. Okay, and let's just say age because we are writing out age like this. Okay, now if I run this code, what do you expect to see? And I'm running it, and as you can see, it says before function age is 25, and then it says yay, celebrated 26th birthday, and then it says after function age is again 25. What has happened here? So what has happened here is that this function here, this celebrate birthday, is not receiving this variable, meaning it is not working with this variable here, but it has its own copy, and then whatever it performs of the calculations, it is going to perform those calculations on its own copy, which means that those changes are not going to reflect on this variable here. And that is why we have 25 in this line, and then invoking function, and then again here we have 25, even though we have increased that value here. Now, in order to solve that problem, we will use pointers. So how will I do that? Well, here, instead of passing my age variable, what I can do is I can pass address of this variable. So here, I'm going to say, please pass address of my age variable. And this ampersand symbol here is going to do that. It gives us address of a variable. And as you can see, since we have passed an address here we really have to receive a pointer to address. And in order to do that, I'm going to add this star symbol. Okay, and then let's add it here as well. So here we have passed an address, and then here we have received a pointer. Now, if I run this, we are going to get a problem. It says before function age is 25, and then after function age is 25. But here in our function it says yay, celebrated, and then this here is address. Okay, so this does not make sense. And why has that happened? Because here we have received age as a pointer, and here we are treating it as a pointer as well, meaning that here we are increasing address and not the value that is stored on that address. And in order to do that, in order to access a value, we have to dereference that pointer. So that we do with this star symbol. And I'm going to do it like this. So I'm going to say, please dereference this pointer, meaning access the value that is stored on that address, and then please increment that value. And here as well, I want to access the value rather than the address itself. So I'm going to write out the value, and I'm going to use this star symbol once more. So now when I run my program, as you can see, it says before function age is 25, and then celebrating 26th birthday, and then after that our function, so after our function, our main function has this my age holding value of 26, which means that these changes that we have made here applied to this my age variable. And this is going to allow to your program to have different components of your program accessing same memory locations, meaning sharing data that is stored on those memory locations. And that is one example of how pointers are used in C++. Now, another use of pointers in C++ is going to be using them with arrays. And in order to demonstrate that, I'm going to create an array. Let's make it an array of integers, and let's call it lucky numbers, like this. And I'm going to make it array of 5 integers. And here I will say that my lucky numbers are 1, 3, 5, 7, and 9, for example. And what I want to do here is I want to demonstrate you first what this name of array represents. So I want to write out that like this. So the name of this array really is the address of this array, which is the address of this first element of array. Now if I run this, as you can see, we get an address, but in order to demonstrate that that address is the address of the first element, I'm going to stop the program, and I'm going to copy this line, and here I want to say, please give me this first element, and what I want is I want address of this first element. And now if I run this program, as you can see, we have two of these same addresses, which means that the name of an array is going to be address of its first element. And in order to access the value on that address, you just use this index. So without this ampersand, you say, please give me whatever you can find on this index 0 of my array, because indexing of arrays starts with 0. And if I run this now, as you can see, the value that is stored on this index position is going to be 1. Now, how you can use pointers with this? Well, let's create a pointer which is going to point to int variable, and I'm going to call it, let's say, lucky pointer. Now, is that a meaningful name for a variable? No, I guess, but it's cute, so let's keep it like that. Let's say that our lucky pointer is going to point to whatever address our lucky numbers array is holding, and that is going to be address of our first element, as we already demonstrated. Now, what you can do with this, let me very quickly write out whatever my pointer is pointing to. So I'm going to say pointing to, and then let's write out lucky pointer, so the address that this pointer is storing. And then let's write out as well the value on that address, like this. And, oh, I'm sorry, and we can access that value using this star symbol, which is going to dereference our array, like this, and then add end line at the end. Now, if I run this program, as you can see here, we have this pointing to the same address as we did in this situation here, and then the value that is stored on that address is going to be 1, same as here, which is the first element of our array. Now, what I want to do with this pointer is I want to increment it. So I want to say lucky pointer plus plus, which is just going to increment the address, meaning that now our pointer is going to move to the second element. And now if I copy this again here and I run my program once more, as you can see, now our pointer is pointing to the second address, the address of our second element, and the value that is stored there is going to be 3, which is the value of our second element of our array. Now, this was an example of how you can use pointer in combination with arrays, and this here can give you the possibility to iterate through your lucky numbers array by incrementing the value of your lucky pointer. Now, one thing that you will have to be careful with is going to be to not access memory addresses that are not yours, which means that this lucky numbers array has 5 elements. The first one starts with 0 and the last one ends with index 4. And that means if you try to access addresses with indexes 5 and 6 and 7 and so on, those are memory addresses that are not yours, meaning those memory addresses don't belong to your lucky numbers array. And if you try to do that, there are many issues that can arise from there. One very important thing that I haven't mentioned so far is that C++ is object-oriented language. Now, what that means? What is object-oriented programming? Well, object-oriented programming allows us to represent real-life objects in programming, and those real-life objects are going to be represented together with their properties or attributes and then their behaviors as well. One of the most important concepts of OOP are classes and objects. Now, a class is a blueprint, a template, and then an object is going to be a concrete example of that class or an instance of that class. For example, a class can be an animal, and then an object is going to be a concrete example of that animal. For example, a monkey, a dog, a cat, cow, Or a class can be fruit, and then an example of that class, an object of that class is going to be strawberry, banana, apple, peach, Now, we have already talked about data types in this course, and we have mentioned integer, float, double, string, boolean, And what a class is as well data type, but it is user-defined data type. Now, how can you define your own class? How can you make your own class? Well, in order to do that, I'm going to go here, and here let's create a class that is going to be called car, for example. So in order to do that, I'm going to type class, and then I'm going to give it a name car, like this, and don't forget to put this semicolon at the end. And then here in this car class, what I want to do is I want to define properties of my class. Now let's say that this car is going to have string name, so it is going to have property that is called name, and that is going to be of type string. And then let's say, for example, that our car is going to have as well string color, like this. And then let's give it another property. Let's say that it is going to be, for example, double price, like this. Now a regular, double, like this. Now a regular car is going to have many more properties than just these three, but in order to demonstrate how classes are created and used, I'm going to use just these three properties. Okay, now how can you create a variable that is going to have this type? So how can you create a variable, an object of type car? In order to do that, I'm going to go here and I'm going to say car, and then let's create a car. Let's say that that variable is going to be called my car, like this. Okay, now we have created a variable, an object of type car. And in order to set value to these properties, what I can do is I can say my car, like this, and then if I press dot, these properties should appear. However, they are not appearing. And why is that case? Why is that not happening? Because in C++, all the properties, all the members of your class are going to be private by default. And that means that they are going to be accessible only within this class. Now, if you want to make those accessible outside of your class, what you have to do is you have to put access modifier, which is going to be public. So now, when I put public here, these properties should be available outside of my class. And if I press dot here again, as you can see, these appeared. So we have color, name, and price. Now let's set the name of my car. And let's say that the name is going to be, for example, Ford, like this. And then I'm going to copy this a couple more times. So I'm going to set the color of my car, and I'm going to say that the color is, let's say, red. And then let's set price as well. So let's say that the price is going to be, let's say, the price is of type double. So we are going to assign that as we should. So let's say that the price is, what is this? 50,000. Okay, that's okay for a Ford. Now, we have created an object of this class car. Now, what I can do with this, let's write out these properties. Let's say that we want to write out all of these properties. So in order to do that, I'm going to say cout, and then let's write name, name, like this. And then I'm going to say my car dot name. And I'm going to copy this a couple more times. So let's write out a color of my car. I'm going to say here color, and then let's write out price as well here. And I'm going to add, for this price, I'm going to add dollars at the end, like this. So now if I run my program, as you can see, it says you have a car which is Ford, and that car is red, and it costs $50,000. Okay, now if I wanted to create another car, what I would do is I would copy this and then paste it here, and let's call that car my car 2. And here I'm going to say that my car 2.name is going to be Volvo, Volvo, and then my car 2.color is going to be black, and here my car 2.price will be, for example, $70,000. And in order to write out these properties of my Volvo, I will copy this and then paste it here, and here I'm going to say my car 2, and then here and here as well. So now if I run my program, we will get information about both our Ford and then our Volvo. However, writing this is a bit tedious. So now I'm going to show you how you can do this in an easier way. In this chapter, I want to talk about constructors, and a constructor is a method that is called automatically when you create an instance of a class. So when you create an object, a constructor of that class is called. Now, so far we had to assign values to these properties like this, so we had to do that manually, and then here as well. But if we had a constructor, we could assign these values on the construction of our object. So let's create a constructor. And in order to create a constructor, we are going to do that in our class. And there are two important rules. The first one is that constructor does not have a return type. And then the second one is that the constructor has the same name as your class. So car, like this. This would be an example of constructor. Now, because I want to assign values to these variables on the construction of my car, I'm going to pass these parameters to my constructor. So here I will say string name, and then string color, and then double price, like this. Okay, and what I want to do with these parameters that I have received in my class, I want to assign them to the variables. So I want to say name is going to be equal to the name that I received in my constructor. Name, like this. And then color is going to be equal to the color that I received in my constructor. And then price is going to be equal to that price that we have received in our constructor as well. Now, what I can do instead of this here is I can say here that my car is going to have initial values of Ford, and then color is going to be red, and then it is going to cost $50,000, like this. And now I can delete these because I have already created my car like this, and I have assigned values to these properties in my constructor. And then we can do the same thing with our second car. So I'm going to remove this, and I'm going to move my car here. And let's say that our second car is going to be, again, Volvo, and the color is going to be black, and that is going to cost $70,000. Okay, now when I created these two objects, these should behave the same. So if I run my program, as you can see, we still have these informations about our Ford and then our Volvo. Another important thing is going to be class methods. And in order to represent a behavior of a class, you are going to use class method, which is going to be basically a function. So far we had these attributes of our class written out here and then here as well, which means that we have repeated this code. So we have written out attributes of our Ford and then attributes of our Volvo, repeating this code. However, we can move this code to our class, so I'm going to cut it from here, and then here I want to create a method which is going to do that job. So I'm going to say void, and then let's call that method getInfo, like this. And what I want to do in this method is what we have done here. So here I'm going to delete this mycar2, and then this color as well, and then price. Okay, and that is because these properties are accessible directly within this class. So we don't have to access these properties through an object, but these are directly in the class. Okay, so now if I delete this as well, and I say, for example, mycar.getInfo, and then let's say mycar2.getInfo, we should get that same information as we did before. So I'm running my program, and as you can see, it says Ford, red color, $50,000, and then Volvo, black, $70,000. So that would be an example of class method. Three most important characteristics of OOP are encapsulation, inheritance, and polymorphism. And in this chapter, I want to talk about encapsulation. So what is this rule of encapsulation? Rule of encapsulation says that these properties of your class should not be public, meaning these should not be available for your user so that he can change them as he wants, but you should rather create some methods that your user can invoke, and then through those methods, obeying the rules of those methods, he can change this data. And now we are not obeying that rule of encapsulation because we have said that everything in our class is public. And now I can say my car dot, and then as you can see, we have this color and the name and then price property as well. These are available for us outside of this class. And in order to obey this rule of encapsulation, what I will do is I will make these to be private. So I'm going to say here private, like this, and then these, my constructor, and then this getInfo method, these are going to stay public. So I'm going to put that access modifier here. Now, if I try to access these three properties outside of my class now, as you can see, these are not available anymore. The only thing that is available is my getInfo method, and then my constructor is available as well, and we invoke that here. Okay, now how am I going to access these properties of my class now that they are private? Well, what you can do is you can create get and set methods. So you can create method that is called getName and setName, which are going to get you name and then set the value of name, and then you can create get color and set color, get price, set price. But what I want to do here is I want to give you another example. So let me add another property. Let's say that that property is going to be of type bool, and that property is going to be is broken, like this. And what this property should represent, it should represent whether our car is broken or not. And I'm going to assign the value to this property in my constructor. So initially, when my car is created, I want to say that that car is not broken. So here I'm going to say is broken is equal to false, like this. Okay, now how I want to allow my user to change this property. I'm going to collapse this once more, and in order to allow my user to change this property, I'm going to create two methods. And those two methods are going to be, for example, crash car and then repair car. And our crash car method should set this property to be true. So our car is broken after it crashes. And then after it is repaired, our car is not going to be broken anymore. So I'm going to say void crash car, like this. And then here I want to write out a message, cout. And let's write out the name of our car first. And let's say crashed, like this. Okay, and here I want to set as well this is broken property. So I want to say once my car crashes, I will set this is broken to true because my car is broken then. And then let's create another method. Let's say repair car, like this. Okay, and here I want to say car repaired, like this. And I want to set the value of this is broken to false, because after my car is repaired, it is not broken anymore. Okay, and now after we have hidden these properties and then exposed these two methods, what we should be able to do is access these public methods, and then these should not be available anymore. So now if I try to access the properties of my car, as you can see, the only available ones, so the only available members of my class are going to be crash car, get info, and then repair car, and all the other properties are going to be private, meaning not available outside of my class. Now, what I want to do in order to test these two methods, let's create another method. Let's create a third method, which is going to be, for example, void move, because cars can move. So what I want to do in this method is I want to check. I will check if is car broken. And now if the car is broken, what I will do is I will say cout car, so the name of my car, and then let's write out broken. Let's write out is broken. Okay, and line like this. And then if the car is not broken, else I'm going to write something else, and that is going to be car is driving, like this. Great. Okay, now after we have created these three methods, what I will do here is I will try to say my car, and let's rename this. Let's rename this to be named Ford, and then let's call this other to be Volvo. Okay, now here I'm going to say Ford dot move, like this, and if I run this, as you can see, Ford is driving. Now let's try to tamper with this is broken property. If I try to say Ford dot is broken, that is not available anymore. However, what I can do is I can crash my car. So I can say Ford dot crash car, and then after I have crashed it, let's try to move it then. So here I'm going to say Ford dot move again, and as you can see, Ford is driving, and then I crashed my Ford, and then it says Ford is broken, so you cannot drive your Ford anymore. Okay, now if I stop this and then I try to repair my car, so I say Ford dot repair, like this, and then I try to move it again. Oh, I try to move it again, and we are missing this semicolon here, and I run my program. As you can see, it says Ford is repaired now, and then you can drive your Ford. So then Ford is driving. And that would be an example of encapsulation. So we have hidden all of these properties from our user. We have made these to be private, and then we have exposed methods, which are these three, which our user can invoke. And then in this method, for example, he can tamper with this is broken property. So obeying the rules of this method, he can change is broken property. Now, these two methods, this crash car and then this repair car, would be much more complex in real life. So for example, in this crash car, you would have to check how serious that crash is. So if the car is crashed to the point that it cannot drive anymore, and then in this repair method, you would have to check probably whether the car is even repairable. So how the serious damage is, but for this example, we have just said that once the car crashes, it is broken, and then once you even try to repair your car, it is repaired. Okay. Another very important characteristic of OOP is inheritance. So I'm going to explain how inheritance works in C++ on a simple example. So here we have this car class, and this class has four properties. It has name, color, price, and then this is broken property. And we have defined as well a couple of methods for our car. So we have defined this get info, and then crash car, repair car, and move. And we have made a constructor for our car as well. Now, what is going to happen if I wanted to create another car, another type of car, a very, very special one, which is going to be, for example, a flying car. And then that flying car should have these same methods and properties as our car. So it should have a name, and then a color, price, is broken property, and then it should have as well the ability to get information about that car, and then that car should be able to crash and repair and move as well. So what we should do probably is we should copy all of these, right? Wrong. In C++, we can use inheritance in order to inherit all of these members of a class in another class. So here I can create another class, which is going to be called, let's say, class flying car, like this. And then what I can do in order to inherit this class is I will put this column sign, and then I'm going to say public car, like this. Now, there are a couple of things that I want to explain here. And the first thing is going to be that this flying car class is called derived class. And then this car class that we are inheriting from, that is called base class. Now, this public modifier, it says that whatever is public here, so whatever is public in this car, it is going to be public here as well. Okay, so now after we have created this flying car should have everything the same as this car here does. So let me create an instance of this class. So I'm going to say flying car, like this, and let's call it flying car. And here I want to create my flying car. So I want to create these properties for my flying car. So let's say that the name of my flying car is going to be, what's a good name for a flying car? Let's say Sky Fury, like this. And then color is going to be, for example, black. And it should cost, let's say $500,000, like this. Is that too much though? I don't know. Okay, now once we have created this, as you can see, we have this error. So I'm going to end this command and I'm going to return to this arrow. It says no instance of constructor, meaning that this flying car does not have a constructor, and we have passed these 3 arguments, but there is no constructor to receive them. So here I'm going to create a constructor and I'm going to say flying car, like this. And then here in this constructor, I want to receive these 3. So I'm going to copy them from this constructor here, like this. And then what I want to do, instead of instantiating these 3 properties here in our flying car class, I want to invoke my base class constructor, and I can do that. So I'm going to set this colon sign, and then I'm going to say, please invoke my car constructor. And then since my car constructor knows how to instantiate these properties, I'm going to pass these properties to it. So I'm going to say, you are going to receive name and then color and price as well, and you deal with those. Okay, now this should be all set, but as you can see, we still have this error here. Now what this error says now, it says that the constructor is inaccessible. So why is it inaccessible? Because if you remember, all the members of a class are private by default, and private members cannot be accessed from outside the class. So in order to make this constructor accessible, I'm going to make it public. So I'm going to say here public, like this. And now this error should disappear. Okay, now we have successfully created flying car. And the principle of inheritance says that this derived class, this flying car, should be able to access methods from this class here. So it should be able to access public methods and protected methods and properties as well from its base class. So now if I try to say flying car dot, as you can see, we get all of these public methods from our base class. And let's say that we want to write out information about our flying car, like this. And if I run my program now, you can see that we have successfully written out the information about our flying car. So it says name is Sky Fury, and then color is black. It should be black. Okay, I'm going to correct that. And then price is, what is this? $500,000. Okay, so the color of our car should be black. Okay, now we have successfully accessed method that was defined in our base class, and we have accessed that method from our derived class. And we have been able to do that using inheritance. Another very important concept related to OOP is polymorphism. Now, a polymorphism describes the ability of an object to have multiple forms, to have many forms. Now, in this particular situation, we have this car, and then we have created a derived class of this car, and we have called it flying car. And let's create another class in order to demonstrate how polymorphism works. So I'm going to create another derived class, and I'm going to copy this flying car, and then let's say that this derived class is going to be called underwater car, like this, and let's make its constructor underwater car as well. Okay, now after I have created this underwater car, what I want to do is I want to create an object of that. So I'm going to copy this and then paste it here, and let's say here that it is going to be called underwater car, like this, and the name should be, let's say, Sea Storm, and the color should be blue, and then let's make it 600,000, for example. And now what we should be able to do in polymorphism is to have the same method, the method that has same name but different implementation. And in order to demonstrate that, I'm going to use this move method that we have already created in our car, and it is a method that checks whether our car is broken, and if it is, it says that the car is broken, and then if it is not, it says that the car is driving. And that is the situation with our car, so with our base class. Now I'm going to copy this method and I'm going to make different implementation of this method here. So here, what I want to change is that my flying car is not driving, but it is flying. So that is different implementation. And then for our underwater car, what I want to do is I want to say that my underwater car is diving, for example. Okay, now these are some errors that we got, and this name and then this broken property, they say that the member is inaccessible. Now, why is that happening? This has nothing to do with polymorphism, but it has to do rather with this access modifier. We have said here in our car that these properties, these four are private, and that means that these four are going to be accessible only within this class. So you are going to be able to access these only from this class. Now, in order to make these accessible outside of the class, you would make those public, but we don't want to do that. What we want to do is we want to make these accessible from derived classes, and there is a third access modifier that is going to do that, and that is protected access modifier. So I'm going to create that here. I'm going to say protected like this, and then I'm going to move this name, and then this is broken to my protected area like this. And now we should be able to access these two from our derived classes. And if I scroll down, as you can see, the errors disappeared. Okay, now we can access is broken and then name. So returning to polymorphism, we have implemented this move method in our underwater car, and in our underwater car it says that the car is diving, and then in our flying car it says that the car is flying, and then in our car class it says that the car is driving. So what am I going to do now? I'm going to create, or I'm going to actually invoke this method for these three objects. So I'm going to copy my Ford, that is just base car class, and I'm going to say Ford.move like this. And then let's copy this 2 more times, and I'm going to invoke the same method for my flying car, and then the same method for my underwater car, like this. And if I try to run my program now, as you can see, each of these objects has invoked its own method. So Ford is driving, and then Sky Fury is flying, and Sea Storm is diving, which is okay. So you can do that with polymorphism. So you can have the same method, the method that has same name but different implementation. Now, there is also one interesting thing that is related to polymorphism as well, and I'm going to demonstrate that in a minute. So if you remember, when we talked about pointers, we said that pointer is going to hold an address of a variable, and we said that pointer is going to point to the same data type that that pointer has. So if I create, for example, an integer variable like this, and let's assign it a value of 5, and now I want to create a pointer that is going to point to this variable. I'm going to say int pointer, and then let's say int pointer like this, and I want to assign it the address of this variable here. So I'm going to say please assign the address of this variable like this. Now this is okay, this works. However, if I try to change this, the type of my variable, if I try to change that to float, for example, like this, as you can see, we are getting an error. It says a value of type float pointer cannot be used to initialize an entity of type int pointer. So you cannot do this. Now, what you can do in polymorphism is you can have a pointer of the base class pointing to an object of derived class. So let me demonstrate that. I'm going to delete this example here. And what I want to do is I want to create a pointer of type car like this. And let's call that pointer car1. And what I want to assign to that pointer is going to be an address of flying car. So I'm going to say assign address of flying car, like this. And let's copy this once more. And here I'm going to say car 2. And to this car 2 pointer, I want to assign address of my underwater car. Okay, now after I have done this, what I can do is now I can invoke methods using this pointer for this flying car and then for this underwater car. So here I'm going to say, let's say for example, car 1, and then let's invoke a method that is called crash car. And if you noticed, it has changed my dot to this symbol here because this is used when you want to invoke a method using a pointer. Okay, so I'm going to say car 1 crash car, and then this crash car is a method that we have implemented previously, and that is this one here. It just says that the car crashed, and then it changes the property of a car to this is broken property of a car to true, and then you cannot drive that car later, so you cannot move that car because it is broken. Okay, I'm going to collapse this again, and then I'm going to return here. And this method that I have invoked on my first car, let's do that with the second car as well. So let's do that with my underwater car. Okay, and now if I run my program, as you can see, it says Ford is driving, Sky Fury is flying, Storm is diving, Sea Storm is diving. Those are these three methods, and then here we have invoked these crash car methods, and it says Sky Fury crashed, Sea Storm crashed as well. And now if I try to invoke these methods once more, let's see, and I run my program again, as you can see, it says these three lines, these three last lines say that for this driving we haven't crashed that, but our Sky Fury is broken and then our Sea Storm is broken as well. Now let's repair those. I'm going to copy this and I'm going to invoke the repair method instead. So I'm going to say repair car, and then here I want to repair my underwater car as well using this notation here. So I'm going to invoke these methods again just to see if they are going to move again after this. And if I run it, you can see that these last three lines indicate that Ford is driving, Sky Fury is flying, and then Sea Storm is diving. And before that, we have successfully repaired our Sky Fury and then our Sea Storm as well using this here. So that is something that you can do using polymorphism. So you can invoke this repair car and then this crash car method for your flying car and your underwater car, which are derived classes. You can do that using this base class pointer. I hope that you enjoyed this video, and if you did, give it a big thumbs up, and also subscribe to Traversy Media and the Code Beauty channel as well, and I hope to see you in some other video. Bye! And then let's change the name to be, for example, Sea Storm, like this, and then color should be blue, and the price, what is this? $500,000. Let's say that it is going to be 400,000, so it is going to be a bit cheaper than this flying car. Should it though? When you're driving underwater, you're dealing with a lot of pressure. That's not cheap. Is a submarine cheaper than an airplane?
"2,000 years later."
Let's just not answer that question right now. And let's assign a name to my car. So let's say that it is going to be, for example, Koenigsegg. Why not? Like this. Okay. And then, no, I'm going to make a typo. Let's use BMW instead. Ljubavi moja, svi su vozovi odavno otišli sa perona, ostajem svoja, pa nek me voli neko bolji od tebe. Na sva zvona pamćenje bit će mi kratko zaboravljam.